I welcome everyone to this lesson on enantiomers. Enantiomers are two optical isomers that have the plus and negative sign. Their opposite rotatory powers are due to the opposite arrangement of groups around a chiral carbon. These molecules are not superimposable on their mirror image. What is chirality? A chiral carbon is a carbon which is bonded to 4 different groups and it is termed as handedness. The carbon in figure 1 is a chiral carbon. It is bonded to a carboxylic group, COOH group, an arrow group which may be alkyl or aryl, which is methyl or ethyl. It is also bonded to an NH2 group, an amino group, and a hydrogen atom group, represented by H. It is an example of a chiral carbon. A chiral carbon lacks the plane of symmetry, and it is referred as asymmetric or disymmetric. A chiral object cannot be superimposed on its mirror image. We have here in figure 1 the left hand and the right hand. A left hand mirror image is not another left hand, but a right hand. The two hands are not identical and cannot be superimposed. If we lay one hand on the other, the finger and the thumb will not fit. Enantiomers. Let us use 2-chlorobutane as an example of an enantiomer as shown in figure 2. 4 groups are attached to 2-chlorobutane. They are the chloride group, the methyl group, the ethyl group, and hydrogen group. And the mirror image of 2-chlorobutane has the chloride group, the ethyl group, the methyl group, and hydrogen. If we superimpose the one on the right on the left, we will observe that they are not superimposable, as the position of the methyl group on the mirror image on the left will be taken over by the ethyl group, while the ethyl group position will be taken over by the methyl group. Their optical presentations are different, so they are called enantiomers. As shown in figure 3, the structure of R2-chlorobutane and S2-chlorobutane, they differ in their direction in which they rotate the plane polarized light. When a molecule is denoted dextrorotatory, it rotates the polarized light clockwise and has the symbol of plus. When it rotates anticlockwise, it is denoted as minus and can be called level rotatory. Note that enantiomers are not superimposable mirror image. The left hand and right hand in an chiral environment have identical surrounding atoms and groups, meaning their nuclear environment are the same, and so they have no spectral differences. Consequently, their complete constants and chemical shift for corresponding nuclei are also the same. Their spectrum will be indistinguishable and will appear as one peak in an NMR spectrum. In an NMR spectrum, enantiomers appear as one peak. Enantiomers form what we call racemic mixtures. A racemic mixture is a 50-50 mixture of two enantiomers. Such a mixture is optically inactive because the two mixtures rotate the plane polarized light equally in opposite direction and cancel each other. Another example of enantiomer is lactic acid. Lactic acid contains one chiral carbon as shown in figure 4 that is joined to 4 groups: a carboxylic group, COH, a hydroxyl group, OH, a methyl group, CH3, and a hydrogen atom, H. Lactic acid is an organic acid the body produces during anaerobic fermentation when cells break down carbohydrates for energy without oxygen. It is also found in some food and used in cosmetics and medication. In the body, it is generated through intense exercise and filtered out by the liver and kidneys. But a buildup can indicate a medical issue. As an ingredient, it is used to exfoliate the skin, preserve medications, and produce fermented foods like cheese and pickles. Enantiomers are a pair of molecules that exist in two forms that cannot be superimposable on each other, but are mirror images of each other. Enantiomers are stable, isolable compounds that differ from one another in three-dimensional spatial arrangements. Enantiomers have identical properties in all respects except in their interaction with plane polarized light. Their melting point, density, solubility, color, and reactivity towards acids and bases are the same. And that is why we say they show one peak in an NMRO spectrum. Looking at the optical representation of lactic acid as shown in figure 5, a solid line represents a bond that is in the plane as the paper or screen. In a tetrahedral drawing, this notation shows a bond that lies flat, allowing the other bonds to be shown projecting towards or away from the viewer. A solid triangular wedge represents a bond that is coming out of the page towards the observer. It is often thickened to emphasize that it projects forward in space. And a dashed line represents a bond receding away from the observer, going back behind the plane of the page. Enantiomers, we have said, are non-superimposable mirror images. So this lesson is short. I want you to answer the following questions. We have here 4 structures, structure 1, 2, 3, and 4. Which of these molecules, 1, 2, 3, or 4, are enantiomers of each other? What is an enantiomer? Can enantiomers be separated? How are enantiomers different from each other? What is a racemic mixture? Calculate the molecular formula of lactic acid C3H6O3 and tartaric acid C4H6O6. List the functional groups in lactic acid and tartaric acid. Which of these acids are polar or non-polar, given your reasons? We have come to the end of this lesson, and I want you to please subscribe, like, and share my channel. Share with your friends. Thank you for watching this video to the end. See you in the next lecture.